At the end of the first stage of its growth cycle, a species of tree has a height of 5 meters and the trunk radius of 15 centimeters. In the second stage of its growth cycle, the tree stays at this height, which is 5 meters, for the next 10 years. However, the growth rate of the trunk radius varies over the 10 years and is given by the function RT equals 1.5 plus sine pi t on 5. So this is our growth rate of the radius. So if r was our radius, then this is the same as dr dt. Assume the density mass per unit volume of the tree trunk is approximately 1 gram per centimeter cubed, and the tree trunk is in the shape of a cylinder. Determine the ratio of the trunk's mass at the end of the second stage to its mass at the end of the first stage. Mass is given by density times volume. And as density is the same, the ratio of M1 to M2 will be the same as ratio of V1 to V2, like volume 1 to volume 2. And volume 1 will be given by pi r squared h, and volume 2 will be given by pi, let's call this r1, by r2, the radius at the end of second stage, squared h. Now we're told that the height remains same at 5 and pi is the same. So only thing that's changing is the radius squared. So the ratio between the masses will be the same as the ratio between the volume, which will be the same as the ratios between r1 squared and r2 squared. So radius 1 squared to radius 2 squared. So let's do that. So in stage 1, the radius is 15 centimeters. And in stage 2, for stage 2, we know the growth rate of the radius. So this is essentially dr dt. So to get what r is, we'll have to integrate that first. So let's integrate. To get rt, let's integrate 1.5 plus sine pi t over 5. And that's going to be 1.5 t sine cos negative sine. Sine integrates to negative cos. I have negative cos pi t over 5. And we're also going to divide by what's in the bracket. So remember, when you divide by a fraction, it's the same as flipping over the fraction. Plus c. Now we also need to find c. And we can do that because we know that at time 0, the radius was 15 centimeters. So let's sub that in. Cos 0 is 1. Alright, so our function is going to be 1.5 t minus 5 cos pi t on 5 all over pi plus 15 plus 5 over pi. And we want to find that at time t. So r10 is going to be 1.5 times 10 minus 5 over pi cos 10 pi over 5 plus 15 plus 5 over pi. So that is going to be 15 minus 5 pi. Cos of 2 pi is just 1 plus 15 plus 5 over pi. That is going to be minus 5 over pi plus 5 over pi will cancel. 15 plus 15 is 30. So our second radius, if I write up here, is going to be 30 centimeters. And we know that our ratio of the mass is going to be the ratio of r1 squared to r2 squared. So that's going to be 15 squared to 30 squared. That's 225 to 900. And so let's simplify that. If I divide by 25, this will give me 9. And this will be, so there's 4 25s in 100, and there's 9 100s, so 4 times 9, 36. And if we simplify that further, dividing by 9 is 1 to 4. M1 to M2 is 1 to 4. So mass at end of second stage is 4 times end of first stage.